Okay, this tutorial is going to be on addition and subtraction of fractions, which I find a bit more difficult than simplifying fractions. It's not too bad as long as we know how to find a lowest common denominator. We can only add or subtract fractions when we have a lowest common denominator. Now, the thing to remember with a lowest common denominator is ultimately you don't want to change the meaning of a fraction, which means if I have a fraction of a half, I'm not allowed to change the meaning of a half, but I can convert it to what we call an equivalent fraction. Now, the thing to remember with converting to equivalent fractions is if you multiply the top by 3, you have to multiply the bottom by 3. Then you will get a fraction which is the same thing. If you divide the top by 4, you need to divide the bottom by 4. Then you will get a fraction which is equivalent to a half. So whatever you do to the top, you do to the bottom if you're trying to convert to an equivalent form of that fraction. So let's have a look at our first example. Our first example has some algebra in it, and it has some simple denominators, a denominator of 2 and a denominator of 6, and it says simplify. And immediately I need to identify I'm subtracting. So this is not factorizing and cancelling one term over one term and then cancelling. Absolutely different story. I'm subtracting, which means I need a lowest common denominator. Now, as soon as I'm doing algebraic fractions, one of the biggest mistakes is to forget that that numerator is a unit, and this numerator is a unit. So as soon as I get algebraic fractions where I'm adding or subtracting and there's more than one term at the top, I put it in brackets, and I'll show you where those brackets are going to become in handy. Well, this shouldn't be too bad. I'm making a lowest common denominator between the numbers 2 and 6. So what is the number that 2 can go into and 6 can go into? Preferably the lowest number because it makes it easiest, and that number is 6. So I've got to ask myself, how do I take that denominator to 6? What do I need to multiply by to get 2 to 6? And I need to multiply by 3. But what you do to the bottom of a fraction, you need to do to the top of a fraction if you're converting to an equivalent fraction, which is what we're doing here. Now, can you see how important these brackets are going to be? Because this now is 3 times x minus 2, which is distribution. If I've forgotten those brackets, most of us just think it's 3 times x, and we forget that I'm multiplying the entire fraction numerator by 3, which is why I always use brackets. Now there's a minus, and what do I need to multiply 6 by to get to 6? Well, nothing. It is 6. I can multiply by 1, but that's not doing anything. So I'm minusing x plus 1. Now again, can you see how those brackets are so important? If I don't have those brackets there, then I think I'm minusing x, but I'm not. I'm minusing the entire numerator. So always use your brackets. Put them in first so you don't forget them. Okay, now it's quite simple. I need to distribute and collect up like terms, and maybe then I could simplify further, but let's check. So simple distribution, 3 times x, 3 times minus 2. So it's 3x minus 6 minus x minus 1 over 6. Collect up my like terms. 3x take away x, 2x, minus 6 take away 1, minus 7 over 6. Now I'm in a case where I could maybe possibly simplify that fraction, but there's 2 terms at the top. So if I could factorize, maybe I could cancel. But if I look at 2x minus 7, there's no common factor, not a difference of 2 squares, not a trinomial, and I can't do any grouping. So there's no ways I could factorize and simplify that fraction, which means that is the simplest form that that fraction can be. Let's have a look at example 2. Now example 2, what I've done here is deliberately trying to have whole numbers where people start to wonder what the denominators are. Don't be fooled. The denominator of any whole number is just 1. So I would put in those 1s, and I'd immediately put in my brackets at the top there so I don't make a silly mistake. Now it's a lot easier for me to find a lowest common denominator. So what's the smallest number that 1 can go into and 2 can go into? Obviously 2. Now each of those I need to convert to a fraction out of 2, which means that denominator needs to be multiplied by 2, what you do to the bottom, you must do to the top if you're creating an equivalent fraction. So 2 times 1 would give me 2. This denominator needs to be multiplied by 2, so that numerator needs to be multiplied by 2 to create an equivalent fraction. So that's 2x. This denominator needs to be multiplied by, well, I don't have to multiply. I can multiply by 1, or I don't have to do anything, which means this is simply minus. And look how important those brackets are to put in immediately you see the question, so you don't forget them, because that minus belongs to the entire numerator. So now, back to simplify the top, simplify the bottom. 2 plus 2x minus 2x plus 1 over 2. Simplify the top, I see like terms. 2x take away 2x, cancels out. And 2 plus 1 is 3. So actually, you'll end up with 3 over 2, or 1.5, 1 comma 5. But in maths, we generally prefer to leave things as improper fraction rather than decimal. So I would leave that as 3 over 2. So that question was quite important to remind us about those brackets. And don't be afraid of whole numbers. You can just make their denominator an invisible one. Right, let's have a look at this guy. He's getting a bit more complicated. First of all, I don't see 2 terms at the top, so my brackets aren't so important in this question. But I do see a whole number, so I'm going to get confused with that denominator, so I'm going to put in a 1. Now, this denominator looks a bit crazy. I'm going to need to have an a squared minus b squared. I'm going to need to have an a plus b. And I'm going to need to have a b minus a, well, and the 1. But that won't change much. That seems like a bit of a crazy denominator. Now, the thing when you see denominators like this is it's quite important to realize that this might be a complicated form of one of the other denominators. Maybe one of those other denominators is present in this denominator. Now, what I'm saying is I see a squared minus b squared. That's definitely factorizable. So let's factorize it. It's clearly the difference of 2 squares. So I get a minus b and a plus b. Now immediately I've done that, I can see that life is going to be a lot simpler than this complicated LCD, because there's an a plus b and there's an a plus b. I don't have to repeat that factor in my denominator. So my next term is a over a plus b. Now I hope you don't mind, I'm putting these brackets around this denominator because that specific factor has to be visible in the lowest common denominator. So I like to put it in brackets. Now this is great because there's an a plus b and there's an a plus b. So that is clearly part of the lowest common denominator. Now this one isn't looking so good. B minus a. This is a minus b. It looks so similar, but it's not exactly the same. Now this is what we nickname the switcheroo. The thing is that a minus b is not the same thing as b minus a. Subtraction is not commutative. Addition is. So if there was a plus sign, I can easily swap them around and they're the same thing. But subtraction isn't. So how can I make a minus b the same thing as b minus a? I want this b minus a to be the same thing as a minus b, so that it can be a common factor and I can use it in my lowest common denominator as the same thing. Now, those are definitely not equal. If, however, I put a negative 1 outside here, can a minus b be rewritten as b minus a? Now, if we have a look at this, if I multiply my negative 1, that'll give me negative b. And if I multiply my negative 1, I get positive a. So a minus b can be rewritten as b minus a if there's a negative 1 outside. The same goes for b minus a. Could I rewrite that as a minus b? Absolutely, as long as I take out a factor of negative 1. So with the switcheroo, we remember that with a negative sign, you may swap the 2 terms around as long as you change the sign outside. So if I erase this, if I want this denominator here to look like a minus b, it means I need to change the sign outside, which means this can be minus b. Now basically what's happened is minus a plus b plus b. So it is the same thing, but now why I want to do that is that I'm creating a lowest common denominator that's as small as possible. So I want an a minus b to be common in both those denominators, so my denominator is not so complicated. And my last term here was 1 over 1. Now, this is generally what we do with complicated fractions. If I see a complicated fraction question like this, I know that I need to factorize each of those denominators to get the smallest factors possible so I can build the smallest denominator. Otherwise, I'm making my question very complicated. So now let's look at our denominator. We need an a minus b. That has to be in our denominator, and we need an a plus b. But now, this a plus b is already in the denominator, so that guy's fine. This a minus b is already in the denominator, so he's fine. And the 1 will have that as a lowest common denominator as well. So look how small our lowest common denominator is compared to what we started off with in the beginning due to factorizing. Now all I've got to do is figure out what do I need to multiply that denominator by to get to the LCD. In the first term's case, I don't need to multiply anything, so that's 2ab. What do I need to multiply this denominator by? He needs an a minus b, which means you need to multiply the top by a minus b. So I've got a minus b. What does this denominator need to be multiplied by to look like the denominator we've used? He needs to be multiplied by a plus b, which means you need to multiply the top by a plus b. And unfortunately, with the denominator of 1, he needs to be multiplied by a minus b and a plus b. So I've got 1 a minus b, a plus b. All I've got to do now is multiply all those brackets out and collect up like terms. But it's made much easier if I factorize my denominators first. So let's do this quickly. I've got 2ab plus a squared minus ab minus ab, alphabetical always, minus b squared, plus, now this 1 is really not going to do much. If you multiply anything by 1, it doesn't change. So this is a squared plus ab minus ab, alphabetical, and minus b squared, all over our denominator, a minus b, a plus b. So collect up like terms. I've got ab's, 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 and some more ab's. 2ab minus ab is ab, minus another 1 is nothing. And plus ab and minus ab cancel, so all of those ab's cancel out. I've got a squared plus an a squared gives me 2a squared, and I've got minus b squared minus b squared. So that gives me minus 2b squared over a minus b, a plus b. Now, as I said in the previous examples, when you get to a fraction like that, you've got to ask yourself, can I not simplify more? And this looks so promising because I can see that this top numerator here is definitely factorizable. I can first of all take out a common factor of 2. And as soon as I see that, I also know that a squared minus b squared is the difference of 2 squares, which means chances are I can factorize it to 2a minus b, a plus b, and a minus b, a plus b, which means this is quite a rare case where you can further simplify after you've collected up like terms. So don't forget to check. Never be content with a fraction like that. Always check if you can factorize and cancel some more. Now, example 4, we're going to have to do in the next tutorial, so make sure you watch the next one on adding and subtracting fractions.